So about me, my name is Bindesh, and I have over a decade experience working on various cloud technologies like Heroku, Salesforce, many public cloud platforms like AWS, Google Cloud, DigitalOcean. Okay, and my expertise are into uh, DevOps and container technologies. Okay, I've been actively uh, uh, building and helping my clients in building cloud-based solutions by leveraging the same technologies what I'm going to teach. Okay, as a part of this curriculum. Okay, and as far as my credentials are concerned, okay, I have over 15 global certifications, which includes many DevOps and many architect and developer certifications. Okay, all right. So uh, which uh, I strongly believe that I qualify for teaching you this course. Okay, uh, as a part of my daily routine, I make use of all these technologies whatever I'm going to teach you. Okay, so it's not just about bringing some topics and teaching it. Okay, I will try to add value to uh, every single topic. I'll try to bring my industry experience also into my teaching. Okay, all right. Uh, without wasting any time, let's get started. Okay, so let me not make it very formal. Okay, I have the deck, but I personally prefer not to use a deck. Okay, for this. Okay, so let me tell you what exactly we are going to learn. Okay, so first thing, on day one itself, you must have clarity around what a typical DevOps engineer does. Okay. What are the roles and responsibility of a typical DevOps engineer? Because it's a professional course. Okay. So although we will start most of the topics from level 0. Okay, and we will gradually get into some intermediate and advanced topics. Okay, so we do not have any topic here, okay, which is just for filling. Okay, whatever we will learn here, we will delve a deeper dive into it. Okay, we will understand the use cases, okay, and followed by its implementation. Okay, so where it fits into that big implementation or big picture. Okay, so see, DevOps is a very broad term. Okay, so um, in layman terms, you can say the um, DevOps is a set of cultural practices and tools and people which helps you in building your software in quicker successions. Okay, unlike our legacy or old methods in which it used to take around 4 to 6 months at least to bring one version of your software. Now the pace at which new tools and new technologies are coming, we cannot wait for 4 months, 5 months, 6 months to develop one version of the code. Okay, so we want better tools, automated tools, okay, better practices, okay, better culture in which you will develop softwares, okay, which will help you in developing softwares in quicker successions. Okay, so instead of waiting for 4 months, 5 months, 6 months, you should be able to develop some software, some application every day. Okay, and that too without compromising with the quality of your software. Now if you'll completely rely on manual methods, okay, you'll not be able to achieve it. Okay, you have to have some kind of automated mechanism, and that is what we will learn throughout the training, what a typical DevOps engineer does. Okay, there are various tasks that we do as a typical DevOps engineer, a skilled one. Okay, so unlike other roles like developers or testers, they have dedicated tasks. Okay, but being a DevOps engineer, I have to closely work with development team also in order to simplify their lives. Okay, by automating the version control systems, by creating continuous flow for automating code compilation, code review process, okay, integration testings, code deployment from one environment to another, dev to test, test to prod. Okay, so you are simplifying lives of development team also, and at the same time, I heard that some of you, one gentleman said he is from support team. Okay, so being a part of a production support team, what we do, our primary responsibility is to address production related issues. Okay, along with that, we are also responsible for assisting other teams, okay, like development teams, integration teams, okay, testing teams. Okay, the ops team or support team has to also closely work with other teams. So we as a DevOps engineer, our responsibility is to simplify this entire SDLC process. SDLC as in software development lifecycle process. Okay, so the bottom line is anything that helps you in automating your software development lifecycle process. Okay, which makes your software reliable, okay, and which helps you in releasing your software, your application, um, uh, more frequently, okay, in quicker successions. That is what contribute towards the DevOps. Now it can be tool, it can be a person also, it can be a new practice also. Okay, and so DevOps is not just about tools. Okay, so throughout the training we will try to understand, okay, what exactly DevOps is. Okay, and in various stages of our software development process. Okay, what a typical DevOps engineer does. Okay, and what are the different type of tasks that a DevOps engineer performs in his or her daily routine. Okay, so usually the software development process starts with vision. Okay, you will have a client, you will have a customer, or maybe your product owner. Okay, and he or she will have an idea that I would like to develop a website, a software. Okay, that person will share the details with your technical team. Okay, you may have techno functional people like business analysts. Okay, they will sit with the client, try to gather maximum information about the client, then they will share it with what we call them solution architects. Now they are one of the senior most person in the team. Okay, and they will understand the requirement, perform feasibility analysis. Don't worry, all these concepts I will explain in more detail, huh? We have a dedicated module for agile based development also. Okay, and continuous integration and delivery. Because it's a very first meeting. Okay, so let me not get into the technicals right away. Okay, so the solution architect will decide how the solution would look like. Okay, at the technical front. Okay, how many networks will be there, how many servers will be there, how the security of the solution would look like. Okay, how the monitoring solution would look like. Okay, all these things will be analyzed. Okay, how will take backup of something. Okay, and these are analyzed and will get it reviewed from the business person. Okay, once it is reviewed, once the solution is freezed, that's where the development team work starts. Okay, now when I say development team, different type of people are associated with development team, like developers. Okay, um, uh, I'm sharing the screen. Can anyone please confirm if you're able to see my screen? All right, thank you. Okay, so um, so from here the development process starts. Okay, I think most of you are familiar with this process. Okay, so the development team will then start implementing the solution, like writing the code, any kind of configuration files, any kind of scripts. Okay, or if you're a cloud engineer, if you are a developer, if you are a database person like DB admins, okay, or if you are someone who writes SQL queries, okay, they all are part of the development team. Their primary job is to implement the solution. Okay, after getting the requirement from solution architects, okay, in the form of some technical design documents, they will implement it. Then whatever code they will write, okay, it will be pushed into some centralized repo. Okay, all right. So let's say I am working on one module, my fellow team member is working on module 2, this guy is working on login module, I have another person who is working on payment gateway module. We all will write our logic and we will push it into a centralized repo. Okay, the centralized place where everyone's code and logic will be stored. Now from there you will have some automated mechanism. Okay, some automated mechanism which will help you in compiling your code, building your code, reviewing your code. Okay, and it will also help you in moving the code from this repo to some testing environment. Okay, now how it happens, that I will explain later. Okay, so after your application code reaches testing environment, here we perform various levels of testing on our application. Who does it? There will be a dedicated testing team. Okay, how they perform? By making use of different tools. Okay, you have HP tools, you have Selenium, you have a number of different tools which you can use in order to test your application thoroughly. Why would anyone test it? Okay, in order to find bugs, any kind of technical issues. Okay, so testers are meant for making sure that the application behaves in the expected manner. Okay, if any issues are found during the testing, okay, that will be notified, that will be reported back to the developers. Okay, because they were responsible for writing the code, that logic. Again they will fix the issue, push it in the repo. Again the code will be compiled, reviewed, again move to the testing environment. Now this process continues until our application reaches to some satisfactory level. Okay, so if the application looks good, okay, we are no longer we no longer have any bugs, any issues in our application, then we move the code from testing environment to a production environment. Now production is the live environment from where the end users access our application. Okay, so for example, if it is some kind of website or food ordering application or music streaming application, when you deploy the application in production environment, it will be available for end users. Anyone can go to the Play Store, okay, and install my application and make use of my application. Okay. Now, if any issue hits production environment, okay, so there will be a dedicated team called operation teams. Okay, they are responsible for addressing all the production related issues. Okay, we also call them support team. Okay, you may have various levels of support teams, L1, L2, L3, L4. Okay, so depending upon the severity of the issue, okay, how complicated that issue is, okay, we escalate our issues to different support teams. Okay, now, why I'm explaining this? Just to set the context, what a typical DevOps engineer does. Now, if you carefully analyze, okay, this is our conventional, our traditional SDLC method in which there were multiple teams. Okay, we had dev teams, we had integration teams, testing teams, ops teams. Okay, we had architects, BAs. Okay, now look at it from a project manager perspective. How difficult it was to run any project. Okay, you have to have a different expertise, you have to have a different teams to organize. Okay, and the worst part was, okay, there were silos. Okay, there were silos in which people were working, so development team didn't have any idea what testing team is doing, testing team will have no clue what ops team is doing. Okay, and that lead to lot of delays. For example, if I'm a part of a development team, I'll write the code, I'll hand over the code to another team. Okay, so what they will do, they will take a couple of days and they will compile the code, integrate everything. Okay, and they'll perform integrating integration testing and all. Okay, then if they find any issues, they will draft an email. Okay, send me with the report. That will take another day. We will look into it, we will fix the issues again, we will push the code, updated code over here. Okay, so because most of the things were being performed manually. Okay, so that's why we used to have longer deployment cycles. Okay, we wanted some method, okay, some kind of mechanism which will help us and optimize this entire process. Okay, and that's where the continuous integration and delivery process comes in. Okay, so what we do as a part of uh, as a part of automating this software development lifecycle, what we do, we tell the developers to write the code and push it in central repository or a version control system, and rest of the process is completely automated. Okay, so automatically it will be compiled, it will be built, it will be unit tested. Okay, it will be reviewed, it will be automatically moved from one environment to another also, like from dev to test to any other test environment like QA, UAT, dry run. You may have multiple testing environments, and automatically it will also be released into production. Now, nothing happens automatically. Who will automate this entire process? It's the DevOps engineer. Okay, it's the DevOps engineer who simplifies the ops part. Okay, many operation activities that you will automate, and it will also help you in automating the development related tasks, like storing the code in version control system, creating branches over here, creating tags, releases. Okay, it will also help you in this building stage. Now if I have a .NET code, you will compile it differently. If it is Java code, you will compile it differently. Okay, how to build. Java builds are like in the form of jar files, var files. If this would have been a .NET application, it will be exe, msi, dlls. Okay, so depending upon the kind of application that you are developing, okay, accordingly the compilation process and build process and unit testing process changes. Okay, so we as a DevOps engineer, we must know how this entire flow works. Okay, and whatever it takes, okay, to automate this entire thing, okay, falls under the first stack. Okay, which is CI/CD stack. This is what we call it continuous delivery. Okay, continuously developers will write the code and push it in your version control system, and continuously it will be delivered also. We need not wait for months or weeks to bring our functionality in one place and then we'll test it uh, um, thoroughly. Not like that. You just keep writing the code. Okay, and it will this entire process is reusable and standard and tested process. Okay, so every time the developers will push the code, rest of the process will be um automated and it will take care of rest of the things. Now this part is what you will, this entire process is what you as a DevOps engineer will take care of. Okay, as a part of CI/CD stack. Okay, continuous integration and delivery process. This is one of your responsibility. Okay, now apart from that, there are many other things that you have to look after. Okay, another responsibility is creating these environments. Okay, let's say you have a test environment. Okay, you have production environment, you have development environment. In this diagram, we are assuming that there are environments. But what are these environments? Is it a laptop? Is it a PC? Is it virtual machine? It is it a Kubernetes cluster? Okay, or AWS EC2 instance or DigitalOcean Droplet or Google Cloud compute machines. Okay, so what exactly these environments are? It can be virtual or physical machines or physical environments. Who creates it? Earlier, it was cloud engineers. Before that, we used to have physical machines. Okay. Now we need someone who can create this entire infrastructure for us. Okay. All right. So the real world infrastructure would look something like this. Okay. So this is a very simple diagram. Okay. I'll explain it later on. Okay. This is just for reference. So this is how a real world infrastructure would look like. Okay. You will have networks, you will have sub networks, you will have load balancers, NAT gateways, firewalls, security groups. Okay. There are a number of resources. Now, earlier, we used to create, no matter what the application is written in which language, okay, whether it is Java, Ruby, Rust, okay, Python, doesn't matter. Eventually your application code has to land up somewhere. Okay, so it can be a virtual environment, it can be a physical environment. In either case you have to have infrastructure. Okay, so you have to configure it. Okay, let's say I have 100 virtual machines to create n number of networks to create n number of load balancers. Okay, n number of firewalls. Okay, instances to be created, DNS services to be created. Okay, databases, servers to be created. So you have a number of things to set up well before you write the code. Okay, so first of all you have to set up the environment. That is responsibility number 2 of DevOps engineer, to manage your infrastructure. Okay, or you can call it cloud infra, if you're working in the cloud, and that too in an automated fashion, not manually. For manual infra management, you already have many people. Okay, you have cloud engineers, you have cloud administrators. Okay, there are a lot of people out there, those who can manually manage it. But we as a DevOps engineer, our responsibility is to automate this part as well. Okay, how it contribute towards DevOps? Again, by speeding up the software development process. Whatever task it was taking earlier. Yeah. Okay. So if I have to implement or create these resources, okay, it would have taken at least 3 to 4 days manually if I'll create it. If I'll tell you to create the same infrastructure in 3 different environment in dev, test, and prod, okay, and this would have taken almost a week time. Same thing. What I can do is, as a DevOps engineer, I will take maybe a couple of days to write the script for this entire infrastructure using maybe Terraform like tool or Pulumi. Okay, and on the third day, I will be able to use that script any number of times, 3 times, 300 times, or 3000 times. It will hardly take few minutes to set up this entire infrastructure, and that to any number of times. Okay, so that is responsibility number 2. Okay, another responsibility is to um, um, automate container environments. Okay, so you must have a very good understanding of containers. Okay, like you must have heard about Docker. Okay, or Kubernetes. Okay, so let's say you created the infrastructure. Like, let me put it in simple terms. Okay, let's say you have a server. It can be a virtual or physical, uh, doesn't matter. Okay, so this is the place where you would like to deploy your application. Okay, this is your application server. Okay, so it can be a serverless platform also. Okay, but let's assume that this is the place where I would like to deploy my application. Okay, now in order to create the server, you have to have network, you have to have load balancer, you have to have many other things. I'm assuming that server equals rest of the infrastructure also. Now, after creating this server, you would want to configure it. It's not like you just get the machine and you deploy the source code. Not like that. Okay. So first provision the server and then configure it. Okay. So configuring means you will install tools. Okay. There are a lot of things that we do. We create users. Okay. We start services. Okay, we install dependencies. Okay, and we do many more things, huh? So these are the things that you will perform on this machine in order to prepare it for um, running your application. Okay, source code is not yet there. Okay, so this is what we call it configuration management. Okay, I'm assuming that there is only one server, but you can have like hundreds of servers also, huh? Okay, in at enterprise level, okay, you may have hundreds of application server where you would want to install tens of tools. Okay, all right. So first of all, create the infrastructure, then the configuration management process. This is what we call it config management. Okay, or in generic terms, we also call it IT ops activities. Okay, and once it is configured, okay, next step would be to take your source code and deploy it. Okay, that is what you will do it with the help of CI/CD stack. Okay, this is your application source code or your application. Okay, and you will deploy it with the help of CI/CD pipeline. Okay, all right. Now this application can be any application. It can be Java or Python or C or C++, any application. Now, in order to create the infrastructure, you have to have a knowledge of anyone in IAC tool. Okay, infrastructure as a code tool like Terraform or CloudFormation or ARM template or Bicep or Pulumi, okay, or Gearset. Okay, so any such tool you can use in order to set up the infrastructure. Next, in order to configure your environment, you have to have a knowledge of any one config management tool. Okay, like Ansible, Chef, Puppet. In our course, we have Ansible for config management. For infra management, we have Terraform. Now, once the environment is prepared, you have to have a suite of tools which will um, help you in storing your application code somewhere, and then followed by your code compilation and build and unit testing process. For this entire stage, we are going to use Jenkins. Okay, for automating this entire flow, Jenkins will get your source code compiled and reviewed and unit tested using Maven tool. Okay, I'll demonstrate it on Java and Python application. If you want, you can play with other languages also. Okay, here the process is important, huh? Okay, so once your application is fully tested, okay, then what you will do, you will move this application into some test or your production environment. Okay, so now this application packaging can happen in different forms. It can be in the form of tarball. It can be in the form of jar files. It can be in the form of exes. Okay, it can be in the form of Docker images also. Okay, all right. So depending upon the packaging mechanism, you will decide how to deploy this application. Okay, now um, um, now images or Docker images or container images are like a standardized way of packaging your application, unlike your legacy methods where your programming languages were deciding how the application will be packaged. Okay, so with the container images or Docker images, no matter in which language your logic is written, you will have a standardized packaging mechanism. We'll call it Docker images. Okay, so um, 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 in the containers module, we will first try to understand what are containers, how it is different from our conventional application. Okay, and why people and organizations are moving towards containers. Okay, what are the advantages? Okay, and in order to understand it thoroughly, what we will do, we will set up a Docker host. Okay, a machine on which Docker daemon would be running. Okay, and we will deploy containers, and inside the container your application would be running. Okay, so we'll delve a deeper dive into Docker. Okay, we'll start with the container lifecycle process, followed by Docker images. okay, followed by Docker networks, okay, and all these topics, whatever I'm explaining, okay, will be available. Okay, I'll share details with you. Okay, um, DevOps. All right. So where is it? Over here. Okay. So we will explore container lifecycle phases, followed by Docker images, storage, and in order to manage multi-container applications, okay, we will use Docker Compose. Okay, we will deploy at least two applications using Compose. Okay, how a real-world application look like? Okay, and that is going to be a multi-container application. Okay, then there is another project that we are going to implement. Okay, we will integrate our Docker image building and deployment process with Jenkins CI/CD pipeline. That means it will look something like this. Okay, so someone will write the code. Okay, it is going to be a developer. While teaching you, I will help you with some sample code. If you come from a development background, you can write your own application code also. If you are if you do not come from the like development background, I will help you with some sample code. Okay, as far as my background is concerned, I come from Java and Python background. Okay, so I'm familiar with most of the commonly used libraries. Okay, so if required, I will help you with some custom application also. I'll write the code and I'll help you with those application. Otherwise, I have a lot of applications which are ready to use. You can simply download it from my GitHub repo and you can use it for your learning purpose. Okay, so what we will do, we will integrate Docker with our Jenkins pipeline. Okay, so the pipeline would look something like this. Okay, so the pipeline would look something like this. Okay, yeah, we will write the code and end-to-end implementation we will perform here. Okay, I'll demonstrate everything. Okay, uh, and you all can also follow along with me. I'll help you with the lab documents also, huh? So that you can read the document and perform the same activity later on. Okay, so we'll write the code, we will push it in the centralized repo, and we will try to adhere all the recommended practices. Like we will have a multi-branch setup. I will also explain about the Git branching strategy. Okay, what branches you must have, which branch hold what kind of code. Okay, what are feature branches, backbone, integration branches. Okay, and then the Jenkins will pull the code whatever the developers will write and it will process it. Okay, when I say code processing, that means it will perform these things. Okay, it will compile and build and unit test your code. Once it is done, it will create a Docker image and it will push it in the registry. Okay, registry is the place where we store our Docker images. Okay, once it is stored, okay, then we will pull the image and we will deploy our containerized application somewhere. Okay, you cannot deploy your containers anywhere. You have to have a dedicated place, okay, for running your containers, and that is going to be Kubernetes cluster. Okay, so I will also, we have a dedicated module for Kubernetes also, huh? We will start from container orchestration over here. Okay, what do we mean by container orchestration followed by Kubernetes basics? We will set up our Kubernetes cluster using with a single node cluster initially using Minikube. Okay, followed by a production grade cluster. I'll show you how a real world cluster look like with multiple worker nodes. Okay, now after creating the Kubernetes cluster, we will take the application and same image, Docker image, and we'll release it automatically on our Kubernetes cluster. Who will automate? This guy, the Jenkins. Now, what is our contribution into it? Okay, as a DevOps engineer, you have to configure this and you have to configure this. and this, and whatever configuration files, scripts, any kind of settings required in order to implement this entire continuous delivery pipeline. Okay, this continuous delivery flow, okay, will be taken care by you. Okay, so whatever infrastructure is required in order to run your cluster, like networks and servers and whatever it is, okay, you will set it up using Terraform. Jenkins server, it is going to be a virtual machine. Who will create it? Us. Okay, and how? Initially, I will show you how you can set up your Jenkins server manually. Later on, you will automate this part also using Terraform. So you will create this Jenkins server automatically using Terraform, Kubernetes cluster again using Terraform, and this part also you can automate it, but this is something we'll create it manually. Okay, so like this, we will implement at least 4 projects. Okay, all right. First one will look something like this. Okay, we will develop the application, and it is going to be like uh, 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 Java application. Okay, and we will build it using Maven. Okay, and with the help of Jenkins server, we will build it. We will get it reviewed from the tool called SonarQube. Okay, SonarQube is meant for performing static code analysis. Okay, it will check uh, your code quality. Okay, the test code coverage, quality of your code. Okay, just writing the code doesn't mean it will always be a good quality code. Okay, so this guy will help us in improving or refining the quality of our code. Once it is built and reviewed and unit tested, okay, then we will release our code to testing environment. Okay, um, um, although testing is a specialized domain, okay, I'm not going to teach how to test an application, and that is a totally a specialized domain. Okay, so but still I will show you how integration testing and unit testing happens. Okay, and once it is tested, okay, then we will automatically release our application into production environment. Okay, now in order to create our Kubernetes cluster and our production servers, okay, we are going to use AWS. Okay, Amazon Web Services. Okay, so our for second module is going to be Amazon Web Services. Here the objective is not to learn AWS thoroughly. Our objective is to have a cloud environment wherein we can set up our Kubernetes cluster, we can set up our Jenkins server, we can create cloud infrastructure using Terraform. Okay, so you can use any other cloud platform also, huh? Other than AWS, like you can use Azure also, Google Cloud also, DigitalOcean, Alibaba Cloud. Okay, uh, the reason why I will use AWS here is it comes with a free tier account which will be valid for 6 months. Okay, and you get around 7 to 8,000 rupee worth of credit. Okay, which you can consume for all your labs. You need not pay a single penny for practicing your labs. Okay, in Google Cloud you get a 3 months free tier account, and in Microsoft Azure you get only 1 month. Okay, so many times I have seen people like they they could not practice properly. Okay, and all the time they think about cost. Okay, so every lab might cost them more. That's why we use here Amazon Web Services account. Okay, wherein you get some credits. Okay, around 7 to 8,000 rupee worth of credits. Okay, which you can use it for performing all your labs, and it will be valid for 6 months. And after 6 months, if you want to continue your practice, okay, so you can convert your free tier account into your paid subscription also. Okay, and that account will be with you forever, lifetime. Okay, so there won't be any blocker. Even after completion of the training, you will have your lab documents with you. Okay, and the lab documents will look something like this, huh? I'll show you some sample docs. Okay, so like some documents are getting updated. Okay, so the documents will look something like this. Okay, whatever topics I will teach here, if there are any configuration files, like this is a Kubernetes manifest. Okay, um, like a cheat sheet. Okay, small description followed by the labs. Any kind of configuration files are there, so you will find it here itself. Okay, open it and you can download these configuration files. Okay, right from here. Okay, alright, and it will save a lot of time. Okay, I'm not going to use any PPT or any other means for sharing this knowledge with you. Okay, while learning also we will use DevOps methods. Okay, I will share this information with you over GitHub, and if you would like to share anything with me for any kind of review process, or you want me to go through the code that you have written, so you will also do the same thing. You will create your own GitHub account, you will push the code over there, or script or any work. Okay, and then you can share the repo URL with me, or you can make me a collaborator. How to do that I will explain later on. Okay, and I can review your code, and if there are any areas of improvement I can also help you with that. Okay, so those who have already used these tools, they won't find any challenges, but if you are new to like Git or Kubernetes or these tools, okay, so I want you to get used to it. By the time the training will complete, okay, I want you to get used to it. Okay, because see, I have seen in the past in many um, I have been associated with many training partners. I have seen there's a huge gap between what we do in the industry and what most of the learning platforms teach you. Okay, so many times we perform things here with one pod, two pod, and suddenly when you see thousands of pods or thousands of servers in the real environment, okay, sometimes we could not um, figure out, okay, what to do, how to cope up with these many resources, how to write logic. So I want you to have that visibility from day one itself. Okay, that how a real world projects look like, how many people work on it simultaneously. Okay, so this is how you will get an idea, okay, how many people work together in the team, how they contribute. Okay, how they notify other team members. All right, so let me get back to the deck. Okay, so whatever I have just explained, okay, let me try to put it into this tabular form. As far as the cloud and operating system is concerned, cloud we are going to use AWS. Okay, and we will explore around 12 to 15 core services, which include EC2, EKS, VPC, internet gateways, NAT gateways, load balancers. Okay, so like this, we will explore around 12 to 15 core Amazon Web Services, and the same services we will use for setting up our other tools also. Okay, Linux knowledge is super important because almost all the application servers that you will ever find, okay, I would say out of 100 application servers or tools you will find, out of 100 I would say around 85 to 90% will be Linux based. Okay, so you must have a good Linux administration skills. Okay, like basic tasks like creating files, changing the file permission, starting the services, installing softwares. Okay, a typical DevOps engineer does these things numerous times every day. Okay, so I'm not saying Windows Server will not be there. Okay, you may find it, but technologies like Docker and Kubernetes and Ansible and many such tools are Linux based. Okay, these things won't even run directly on the Windows machine. Okay, so we will try to spend more and more time on Linux platform. Okay, followed by infrastructure as a code. For infra management we will use Terraform. Okay, now it has been acquired by IBM. Okay, earlier it was HashiCorp tool, and now it is IBM's HashiCorp Terraform. Okay, all right. Then for version control, we will use Git, and for central a version control system, we will use GitHub. Okay. Then for the CI/CD stack, for this entire CI/CD stack, we will use Jenkins as an automation server, Maven for project orchestration. Okay. Then SonarQube for code review process, and Nexus I will see. Okay, if it is required. Huh? This is for artifact management. Okay, so we will use anyways Docker registry. Okay, if time permits, I will also explain this Nexus. Otherwise we will use Docker registry only. Okay, followed by configuration management tool Ansible. Okay, so Ansible is not going to be a deep dive. Okay, we will we will set up Ansible server and a couple of clients. Okay, I will show you how to write playbooks. Okay, and how you can release any particular task on the client machine. Okay, I will not perform everything on a single machine. We will have two different machines. One place we will write the playbooks, and on another machine we will execute it. How we do it in the real environment. Okay, and there are some core concepts also. Huh? We have modules, we have many other things that we will explore. Okay, as far as container stack is concerned, okay, Docker, it is going to be a deep dive. Okay, followed by Docker Compose. As I earlier said, we will deploy two applications using Compose. Okay. Um, I will also show you how a multi-container application look like. Okay, which will have multiple containers, volumes, networks, configurations, and we will take that application and deploy it using Compose. Okay. Then followed by Kubernetes. Okay. So in the Kubernetes module, we will explore around 12 to 15 API resources, which include pods, replica sets, deployments, config maps, secrets, okay, and services, different type of services like load balancer, cluster IP services, okay, node port services, and there are many other network and storage concepts. In storage, you have persistent volume claim, storage classes, okay. So see, it's being a DevOps engineer. It's not like you have to be you have to be an expert in all these tools. You will not find anyone, okay, in the industry who understand all the tools, all the technologies. But you have to have a good knowledge of some of the commonly used tools. Okay, so for example, if I know GitHub and tomorrow in my project I find Bitbucket, I can work on it. Bitbucket is also Git based tool. Or if I land up on GitLab, okay, so I won't find any challenge, okay, if I know GitHub, because all these tools are Git based. So we will emphasize more on Git. Okay, so that tomorrow instead of GitHub, if you get a Bitbucket or GitLab or Code Commit or Azure Repo, you can comfortably work on it. Okay, all right. Next is the monitoring and observability stack. Okay, so just deploying the application in any environment doesn't suffice the purpose. Okay, after deploying the application into production environment, okay, some of you come from um, like ops team. Okay, you very well know how what was the size of operation teams 5 6 years 7 years back, and how big our support teams are today. Okay, earlier we used to have 10 to 15 people in most of the project, and that too they used to work all three shifts. Okay, now see, you hardly need couple of guys. Okay, most of the monitoring part will be carried out by different tools. Okay, so these tools will constantly monitor your servers, your networks, your applications, and if any issues are reported or if it finds any issues, okay, these kind of tools like Prometheus, sorry, so Prometheus like tools will recognize it, okay, and then it will share those findings with Grafana like tools, and Grafana will help you in analyzing those kind of issues, those kind of performance metrics. Okay, and then if you would like to notify someone, create any ITSM tool tickets. Okay, so that too you can automate it. Okay, so before the end user report that issue, okay, your these tools will, like for example, if 503 error pops up, so immediately Prometheus will, you can write the rule, if any 503 error comes, okay, trigger an alert, trigger an email notification. So immediately your support team will receive an email notification saying that a 503 error has occurred. Okay, do something. Okay, so you need not wait for the end user to report that issue. Okay, so what ops team can do, ops team can proactively take some action. Okay, before the end user raises that issue. So in this tag, what we will do, we will try to understand the post deployment part. Okay, after deploying the application into production environment, okay, how we can monitor our infrastructure, or we can monitor our applications. Okay, in order to understand the performance metrics. Okay, what is the CPU utilization of my machine, memory utilization, network utilization, any kind of application related issues, okay, that I can get it using these kind of tools. Okay, similar tools are like Datadog, Dynatrace, Splunk is there. Okay, Jabix is there. Okay, like this there are many other tools. Okay, Prometheus is open source and it is widely used. Okay, for your cloud resources, for Kubernetes, for Docker, for many tools you can comfortably use it. Okay, and Grafana complements with Prometheus. Both the tools are taken care by CNCF. Okay, Cloud Native Computing Foundation. Okay, both the development and distribution of both the tools are taken care by CNCF. Okay, and along with that, Kubernetes also is a CNCF tool. Okay, so there is a very big open source community who actually contribute towards the development of these open source tools. Okay, and you do not need to purchase any additional licenses in order to use these tools. Okay, followed by programming. Okay, now many time what happens, the tool doesn't helps you. Okay, so every tool has got some limitations. Okay, and if I have a very customized requirement, okay, the customer wants me to um, uh, auto shut down my servers when everyone leaves the office. This kind of functionality I cannot build directly with any tool. Okay, so in such cases, you should be able to write that logic on your own using any programming language. Now, it's not a mandatory skill. Last module is optional. Those who are interested, okay, can attend this session. There will be 2 or 3 sessions based on Python programming, followed by AWS SDK for Python. I will also teach you how you can make use of Python programming language to build a real world automations. Okay, how a Python based real world automation look like. Okay, so that you can leverage Python programming language not just for building console based application. Being a DevOps engineer, believe me, there are n number of places where we have to write custom code. Okay, you cannot completely rely on the tools. Okay, today Jenkins is there, these tools are there, what if tomorrow it discontinues? Okay, just hopping over different tools is not a solution. Okay, so you have to have some kind of development knowledge also, so that if you were to write any custom code, you should be able to do that. So I will assume that you do not come from any development background, and level 0 of Python I will teach. Like we'll start with introduction to Python, then variables, operators, conditional statements, looping statements, functions. Okay, these are some basic concepts um, whose understanding would be expected from you. Okay, many times what we do, it's a like a small thing. Okay, small automation that you have to implement. Okay, and I googled something. Okay, I searched something on ChatGPT, on Google or Gemini or anywhere. I got a piece of code, a snippet, code snippet. Now I must know what to copy. Okay, I have got 10 lines of code and I am interested only in some part of it. So I should be able to understand what the code is written and what part to copy and use it in my logic. Okay, at least you should be able to understand that part. Okay, so Now this module is relevant to everyone. Okay, now those days are gone when people used to say, I'm a tester, I'm not going to learn programming. I'm a developer, it's the job of developer. If I'm a DevOps engineer, I'm not going to write any code. Now those days are gone, no matter who you are. In fact, being an architect also, I write a lot of code many times. Okay, being an enterprise architect or being a SRE also, being a part of any support team member also, many times we have to write code. Okay, so I'm not saying become a hardcore developer, but you have to have a decent amount of knowledge how a typical software gets developed. Okay, because being a DevOps engineer, you will closely work with the development team. Okay, if you do not know how they write code, how they compile it, how they built it, how will you automate it? You cannot automate something which you do not understand. Okay, so the objective of having objective behind having this module is to give you a basic understanding of Python programming language. And in the next section we will install AWS SDK for Python. Code name is Boto3. We will install Boto3, and through Python code, how you can manage your AWS resources programmatically, not through browser, not through command line, through your Python code, how you can create your resources, delete, update your resources. That is what we will see. And at the end, I will also show you an end-to-end implementation, end-to-end automation. Okay, that is going to be Python based. Okay, how a real world Python based automation look like. Okay, all right. So this concludes the course um curriculum. Okay, key offerings. I'll have the presentation which I will use, but I um, I have deck something like this. Okay, I'll use it only for demonstration purpose. Huh? Okay, you will hardly find any description over here. Okay, followed by session recordings. All the sessions will be recorded, which you will be able to stream it immediately after the session, and it will be available with you for a couple of months at least. Okay, next you will get the GitHub access, my repo access, where you will find lab documents of all the activities that we'll perform here from day one itself. Okay, next the projects. Okay, so see, we could have developed a single project in which all these topics would have been there, but uh, it would have um become a complete mess. Okay, if you will include infra things, CI/CD stack, configuration management, then it will become a complete mess. Okay, so the plan is to go step by step. One project for infrastructure related things, another project for CI/CD. There will be two CI/CD pipelines, okay, that we will create. One for your conventional VM deployments, another one for Kubernetes application. Okay, third CI pipeline that we will create for Docker application. Okay, and there is another one which I will tell you later on. Okay, and interview preparation is an optional discussion. We will have one dedicated session for interview related things, like what kind of questions are asked, okay, and how to prepare your profile, some tips and tricks related to interview preparation that we will discuss in this session. It's again optional. Those who are like looking for opportunities, uh, uh, okay, and those who are preparing for interviews, okay, maybe they can attend this session. Otherwise, you can completely skip it. Okay, all right. So we're planning to start this batch from next week. Okay, most probably from Tuesday. Dates and time are not yet confirmed. Okay, ma'am will convey all the details. Okay, most probably next week, Tuesday or max Wednesday. Okay. All right. It is going to be a weekday batch. Okay, every day we will meet for a 1 to 1.5 hour. Okay, timing again it's not yet confirmed. Okay, so ma'am will you'll get a call from your academic coordinators. Okay, you just share your availability with them, and they will try to give you a best possible um, batch timings. Okay. All right. All right. So I'm done it from my end. Okay. Thank you so much for listening patiently to what I was explaining. Now it's time for questions. If you have any doubts or any kind of queries, feel free to shoot your questions. Over to you.
Yeah, when this, so if you are, I mean, if you are using the DevOps strategy in our, right, I think 3 to 4 projects you said. So
Mhm.
can we also plan to use the Salesforce platform? I mean, how
Salesforce we can
DevOps?
use it, but
Mm,
others they have to have some background. And Salesforce is a SaaS. Okay, so you do not have any control over the servers. It uses a PaaS Apex. Again, you cannot bring any external monitoring tool. You cannot bring any external servers. Okay, everything will be managed by Salesforce only. Okay,
mm,
so the only thing you can implement is the CI/CD stack. Okay, gear set like tools you can use it. I have used it for almost 6 7 years on Salesforce. So the only thing you can do is you can have a CI/CD stack, and I have heard that Salesforce has built their own CI/CD stack, so they um, hardly use any external tools uh, for building and deploying application. Another thing is the Salesforce components that you deploy, whether it is classes, triggers, workflows, there is no need to build it. You just lift and shift. You take it from one sandbox and move it to another sandbox. So will not be able to understand what compilation means and what build means. Okay, so in other programming languages what happens, you take the source code, you compile it, and then you convert it into some built artifact like
mm,
exes, msis, apks. Okay, so I would love to like demonstrate it on Salesforce, but in that case we have to have a Salesforce background also, and we have around 10 tools to explore. Every tool has got around 60 to 70 topics. Okay, so anything extra if I'll try to introduce, it will disturb other things also. But I can tell you I have my personal sandbox now, Salesforce sandbox if time permits. Okay,
yeah,
uh,
but I'm specifically looking to the Salesforce platform or DevOps strategy to understand.
but
So,
Salesforce, I can tell you,
mm,
the pipeline will be very much simplified, and
great.
instead of it will look something like this. So instead of this Kubernetes and Docker Hub, what you can do is you can replace this EKS with Salesforce Sandbox. Okay, pipelines, these things will remain as it is, and for registry, because Salesforce doesn't have anything to compile or build. Their build means you're packaging all the classes, flows, configurations together. Okay, that
Mm,
is what we call it build. So we do not have much in terms of building the application also. Okay, so we just, this is the key part, how you integrate Jenkins
mm,
server with your Salesforce environment. So in Jenkins you get a Salesforce plugin. You have to share the user details with Jenkins. Once the integration happens, you just keep pushing the code and it will package and deploy your application here. Okay, so that pipeline will be very much simplified. Rest of the process will remain more or less the same. Okay.
yeah, yeah, fine. But let us know how we can manage this. The expectation.
Again, I'm saying I will not be able to accommodate a very big requirement. If you have maybe a couple of points, maybe I can accommodate it. But if it is about Salesforce, for example, let's say you are expecting Salesforce to be used for the as a application environment. Um, Now, if I'm explaining something related to Salesforce, you know what is Salesforce, I know what is Salesforce, others do not have any idea. Okay, so I have to first give them at least some high level overview what
Yep. Yeah,
Salesforce is.
fine. That's fine. That's fine, Bindesh. But just let me know. I mean, if I can join 1-to-1 session with you, that will be helpful. But I'll
So
get in touch with the radical coordinator, and we'll
you
see
can
how we.
check with them. Okay,
Mm,
if
mm,
they're okay with it, I'm okay with it, because we have very 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 strict timelines. Okay,
okay.
so uh, Yeah, one implementation takes around 2.5, 3 hours, sometimes 3.5 hours also. Okay, so see, as far as technicals are concerned, I'm very much confident. I have done this numerous times. Okay,
Hmm.
as far as additional topics are concerned, okay, you can check with them if they say okay. Okay, I'll also speak with Tom sir if they are okay with it. Okay, I won't mind accommodating it. It will hardly take 3 to 4 or maximum 5 hours. Okay,
Yeah,
if
fine.
if you know what we are going to learn, and if you know what are the challenges, okay, so you can
Yeah,
work on those areas, huh? Okay, it's
yeah,
not like because I come from this background I cannot learn this. Okay, so uh, if others are spending, let's say, 1 hour, you might need to spend 2 3 hours. Okay, that's the only thing. Okay, and this applies to everyone, applies to me also. See, I come from development background. I landed upon containers and public cloud technology, and I know that in next 2 years I will be into some core data technology and AI and machine learning models. I very well know that, so I have to prepare my mind accordingly. Okay, that something is trending. Okay, organizations are demanding. Okay, I will learn, I will get the expertise, and I'll move on. Okay, this is the kind of attitude we have to have. Okay, as far as transitions are
yeah,
concerned,
sure, sure,
let me be
definitely.
very honest with you. Transitions are never easy. Okay, when I moved from Salesforce to Amazon Alexa, my transition was not that easy. Okay, so it took almost 1.5 year to understand the technology thoroughly. Okay, and then I got some opportunities into it. Okay, however, if you will spend enough time, at that time we didn't have good learning portals, we didn't have people to guide. Okay, okay, so now you have people. I'll be there to hold your hand. I will tell you when to learn what, even if something is not part of your syllabus. Like uh, um, one of the gentlemen was asking about the Salesforce integration. Even if something is not part of the syllabus, and if I'm confident on that part, okay, I'll assist you. Don't worry about it. Okay,
Yeah,
I'll stop here, and thank you so much for joining this session. And bye bye.